Hi and good morning. I'm Mr. Rose, and today we're going to be discussing heat. More specifically, in today's lecture, we'll be talking about three methods to heat objects. Those methods are conduction, convection, and radiation. To start, we need a little bit of background information. Here you see a list, and we're trying to figure out which one of these things are good conductors. Now, you may see a trend with aluminum, copper, iron, nickel, and steel, all of those things being metal. And hopefully you've realized that all of those metals are good conductors, which means the other things on our list, glass, polythene, which is a plastic, cardboard, paper, even chocolate, which is delicious, but are not good conductors. Well, in science, we have specific words for things that have good conductors and things that are not good conductors. In science, we have special words for things that are not good conductors, and that word is an insulator. So now here we have a different kind of a list of four things. We have a bottom of a saucepan, like I'm going to cook on, the handle of the saucepan, a quilt, a duvet, a blanket, and an ice cream tub. Which one of these things are good conductors? Well, you might be able to see that I want my saucepan to be a good conductor because that's made of metal. I want the handle of my saucepan to not be a good conductor. I want a quilt or a blanket also to not be a good conductor, and I don't want my ice cream to melt, so I want my ice cream tub to also not be a good conductor. All of those things, very different materials, would all be classified as insulators. Now, some of us may have had this phenomenon happen. You wake up in the morning, you're groggy, you walk across the hardwood floor and your bare feet, it's not a big deal. Then you walk into the bathroom and, oh man, that bathroom floor is cold. Well, what's the difference? Both of them are actually very similar temperatures, but the tile on the bathroom floor is a better conductor than the wood is. And you are obviously touching the wood floor here or the tiled bathroom floor here. So what is actually going on in these two different phenomenons? All of this has to do with conduction. Our last example of this we can see here is if I take a metal spoon, again a metal spoon, that metal being a conductor, and I put it into something very hot, coffee, soup, tea, anything that's really hot, eventually my metal spoon may get really warm. I don't know if I'll need a pot holder, so to speak, but I might get really warm. If I take that metal spoon and put it in my mouth, it's going to get hot. I'm going to burn myself. What is taking place in all of these phenomena? Well, what's happening is we're feeling an increase in temperature. Now, temperature is just the scale, and what we feel is actually the movement of energy. When I was touching the cold floor, I felt my foot heating up the cold floor, energy transferring from my foot into the floor. When you have the spoon, you feel the energy increase in the spoon. What is legitimately happening is all those little molecules, all these atoms inside of the metal, are moving faster and faster and faster. That increase in movement, as we know, is an increase in kinetic energy. So we're increasing the internal kinetic energy of those objects. That's what causes our objects to get hotter. So heating by conduction is heating through direct contact, and what's happening is all of the loosely bound electrons in those better conductors move faster and faster and faster, causing friction internally. It's easy to happen in metals. It's not so easy to happen in non-metals, which are our insulators. Things that we know in real life, you've been outside in the middle of the winter. It could be a very cold but sunny day, and the air is like 25 degrees, but you go outside, you're very warm because air is a poor conductor. Meanwhile, you are feeling the energy from the sun, you get warm. So it's very easy to feel warm when it's cold outside. Moving on to our second heating method is convection. Now all two of these pictures show convection. This third one, that's a little bit tricky, but we see convection here and convection here. So what exactly is this convection? Well, we know hot air rises, and everyone says hot air rises because it's lighter than cold air, but that's not true. Hot air rises because it's less dense than cold air. What that means is the air molecules spread themselves out and they're less dense, they're less packed. Well, cold air, like in a liquid or a gas, sinks because it's more dense. When we have this rising and sinking, that right there is the starting of a convection current. You can think of it like something floating in water. Things float because they're less dense. Hot air floats on top of the cold air because it's less dense. So convection is a phenomenon that happens only in fluids. Now before we had conduction. Conduction was in solid objects. I was just talking about air, and air is a fluid. We can think of air as like almost a very thin liquid, but that's kind of a poor definition. If I take air and I compress it like in a scuba tank, it sounds like it's a liquid. Well, air is this fluid, and what happens is I get to move all of that fluid around just like I can in water. Now, water we should know is made of hydrogen and oxygen. Everybody knows H2O. Well, conduction, I get to move individual atoms. I can't do that with water. So I actually have to have the whole fluid move, all of my water, all of my air. That's what we call a convection current, setting all of the molecules into motion. This is an example of a simple convection current. We may have seen a lava lamp before. There's a heat source down here. The water stays at a different temperature than the wax. We heat the wax up. The hot wax floats up to the top. The cold wax starts to sink down to the bottom, and we get this cute little convection current that's very fun to stare at. This also is how radiators work in a room. We have hot air rising. As the hot air rises, well, my room is a closed system, so all that air has got to go somewhere. It starts pushing the air in circles around, as you can see here. Hot air rises, moving all of that air. Well, eventually I get a gathering of air here, and I have the cold window. The cold air sinks, and this is why you can feel almost like a breeze. This also happens in real life. In real life during the day, water is a good insulator. It's hard to heat up. That also means it's hard to cool down. So the land heats up, we get hot air rising, we get cold air sinking, and we get a breeze coming in from the ocean. The same thing happens over here at night when the ground gets colder. We get the cold air sinking above the ground and then the wind blowing out to sea. If you hang out all day at the beach, you can actually observe this phenomenon. Our last heating method is radiation. Now, radiation is a little tricky. Radiation is heating things through electromagnetic waves. There are lots of different types of electromagnetic waves, and we'll get to that later in the year. But right now, we can just think of these electromagnetic waves as light waves, different types of light. Now, every object emits radiation. It doesn't matter if something is hot or something is cold. We all emit radiation. You can think of this as if you put your hands in front of a fire, you feel that hot fire. Or if you're really, really hot, you're playing a sport and it's cold outside, you can see like heat coming off of somebody. Even night vision goggles, if you've ever looked at night vision goggles or a night camera, your body emits thermal radiation. So we can't see it. It's called infrared radiation. Put on these special goggles and you can see them. Now, anything that can emit radiation also absorbs radiation. If something is easy to heat up, like if you can sit outside in the sun and you get sunburn, your skin actually feels warmer. So if you put your hand above the skin, you would feel that radiate out. And things get to a maximum point. They absorb as much as they can. Once they can't absorb anything else, what they do is they let it go. They release it. All of us have had this experience with a car on a sunny day. If you leave a car parked outside and the sun is beating down on it, when you go into the car is super hot. Well, why does that happen? The sun comes down and it heats up the outside of the car, which is made of metal. It heats up the interior of the car, all of the leather seats or the cloth seats. Well, what happens is once that absorbs as much energy as it can, all of that heat, it starts to let it go. And it releases all of that energy. Well, the windows are made of glass. Glass is a good insulator. So now that new form of energy, so to speak, gets trapped inside of the car. So when you open up the car, it's super hot. All of that is radiation. Things that are bad absorbers of radiation mean it's a good reflector. So if you think about a dark pavement absorbs a lot of radiation, gets really hot. Snow, on the other hand, is white. It reflects a lot of radiation, which is why even when it's warm outside after a sunny day, it holds the snow is slow to melt because it reflects all of that radiation. These are just a couple of other examples, like in the desert. It gets really hot in the afternoon. It gets really cold at night. So a fun little thing to look up is, can you actually make ice in a desert? Sure you can. You don't even need a refrigerator. LFYTD, that just stands for left for you to do. Use Google, look it up. These are just some examples that I'd like you to go through about different types of radiation, shiny objects versus dull objects, absorbing radiation versus releasing radiation. Come into class with questions about these. Types of heat transfer. Each one of these shows a different type of heat transfer. Can you identify which one of these is convection, which one of these is conduction, which one of these is radiation? Is it possible that there are two or even all three heating methods taking place here? And last but not least, everything we spoke about today. Heat summary. Heat is just a measurement of a transform of energy. Heat is energy, which means it can do work. Remember the work-energy theorem. Work and energy are the same thing, which means heat is measured in joules. There are three different methods to transfer heat. There's conduction, there's convection, and there's radiation. What we do want to see here is there are three specific differences and something I didn't point out either. Earlier, radiation. A lot of times radiation can be thought of heating up an object without heating up those surroundings. So in the back of our classroom, there is a snake and there's a bearded dragon who doesn't have a name right now. They sit underneath a hot lamp and they get warm because they get warm from that radiation that warms them, and that doesn't necessarily warm up the air. The classroom isn't really any warmer because of those things. Again, I'm Mr. Rose. If this is on YouTube, please like, comment, and subscribe, and come to class ready to go. Thanks, guys.